Hi guys, you are welcome to another video. So today we are going to be considering the sum and the product of quadratic roots. Okay, the first thing we are going to talk about is that the general appearance of a quadratic equation, which is given as ax squared plus bx plus c is equal to 0. So, and in the last video, we derived the sum and the product of roots. So in this, x, when we have two roots as alpha and beta, so x is equal to alpha and s is equal to beta. So the sum of the root, that is alpha plus beta, we derive that is equal to minus b all over a. This is like a formula. We derived this in the last video. So comparing this equation minus b over a with the question that we are being asked, that is this equation here. So that means we are going to find what a stands for and what b stands for. So a, according to that equation, that is the first term, that is 3. That is 3. While b is equal to 2. So that is 2. So that means our alpha plus beta is going to be equal to minus 2 over 3. Then we also derive the alpha beta to be equal to c over a. So this is the formula for alpha beta. So our c, according to this question, c is equal to 4. That is a constant. So c is equal to 4. That's 4. So that means alpha beta is going to be 4 divided by 3. So let's keep these two values. Let's keep these two values because we are going to need them later on in answering the other two questions, that is the C and the D. So let's keep them. So we have to refer to them later. Okay. So let's go to the C question. Question C. Question C, we are asked to get alpha squared plus beta squared. Okay, what you need to always put in your mind is that when you are dealing with alpha beta, when you are solving questions that have to do with alpha beta and you are being asked to do things like this, you need to look for the expansion of the power outside the bracket. That is, when you are being asked to find alpha squared plus beta squared, you have to find alpha plus beta everything squared. So this is going to be equal to, this is going to be alpha squared plus 2 alpha beta plus beta square. When you expand this correctly, this is what you get. Then this is the next thing you are going to do. The reason why we are doing this is that we want to get only an expression that we are only going to have alpha plus beta, which is the sum of roots, this one, and also alpha beta, because those are the only two things that we know. So let's bring this minus 2 alpha beta to the left hand side. So that means we are going to have alpha plus beta squared minus 2 alpha beta is equal to alpha squared plus beta squared. So this has given us the formula for the question we are being asked to find. So this is like a formula now. So which is what we are being asked to find. We are asked to find alpha squared plus beta squared. So, and luckily for us, we know what alpha plus beta is. We know what alpha beta is. So what we just need to do here is to substitute. You already know that alpha plus beta, we've done that in the first question, is minus 2 over 3. We know that alpha beta is equal to 4 over 3, which is this and this. So we just substitute into the question. So that means this is going to be substitute. So this is going to be minus 2 divided by 3 square. We substitute, remember that we are substituting it into this. Wherever we see alpha plus beta, we put minus 2 over 3. And alpha beta is 4 over 3. So minus, that is 2 times 4 divided by 3. That will give us alpha square plus beta square. So, alright, so we are getting close to the answer. So what we just need to do here, what you are looking for should always be at the left hand side. So this is going to be alpha square plus beta square. Let's take the other one to the right hand side. So but let's expand it as we are doing that. So this is minus 2 square, that's going to be 4 divided by 3 square is going to be 9. So remember we are switching sides. So this is going to be minus 2 times 4, that's going to be minus 8 divided by 3. So let's find the LCM. The LCM is of 9 and 3 is 9. So this is going to be 4. 3 and 9 is 3. 3 times 8 is 24. So 24. So finally our alpha square plus beta square is going to be, so 4, that is minus 20 over 9 divided by 9, which is our final answer. So that is how you go about solving it. So, but the next question is a little bit more challenging in the sense that we are dealing with a higher power. We are dealing with raised to the power of 3. So we are doing raised to the power of 3. But we are still going to follow the same method, the same procedure that we use in getting our alpha square plus beta square. We are going to put alpha plus beta raised to the power of 3. So we are going to put alpha plus beta raised to the power of 3. So always write your value of alpha plus beta on one side. So what's our alpha plus beta? We already calculated it to be alpha plus beta. We've calculated it to be minus 2 over 3. So let's write minus 2 over 3. Minus 2 over 3. While alpha beta is 4 over 3. Alpha beta is 4 over 3. So let's just keep it. Okay, now in order for us to get alpha cube plus beta cube, so we need to look for a formula for this. So I'm getting the formula. We are going to write alpha plus beta. Then we are going to cube it this raised by 3. Then we expand this. Okay, that's what we call the Pascal's triangle. Let me just digress a little. So this is what a Pascal's triangle says. This is raised power 0, and raised power 0, raised power 1. Sorry, raised power 0 is 1. I meant to write 1 here. Raised power 0 is 1. Raised power 1, we have 1, 1. This represent the coefficients. So we add up these two. We add them up. So this is going to be, we always write 1, 1 at the extreme end. Then add up the middle numbers. So 1 plus 1 is 2. So this raised power 2. The raised power 3. This we write 1 at the extreme. So 1 plus, we add up this. So 1 plus 2 is 3. We add 2 plus 1 also, that is 3. Raised power 4. I think we needed raised power 4. We do the same thing. So this is going to be 1 plus 3, that is 4. 3 plus 3, that is 6. 1 plus 3, that is 4. So this is what you use this helps you in doing your expansion without needing to go a long way and solve this. Because if you are asked to solve this, expand this the normal way, it's going to take time and it's going to consume a lot of space. So, but understanding of the Pascal's triangle will help you to do your expansion quickly and conveniently. So, okay. So this raised power 3. So that means we are picking this line. So each of the numbers represent the coefficients. So that means the first one is going to be 1 alpha. And the power of the first alpha is going to be decreasing from 3 to 0. So this is like saying 1 alpha raised by 3, then beta raised by 0. As the power of alpha is decreasing, the power of beta is increasing. Plus 3, remember that we are considering this is what we are considering. So, okay, plus 3 alpha raised by 2, beta raised by 1, plus 3, remember alpha is decreasing, alpha raised by 1, beta raised by 2. Then the last one, plus 1, so your alpha raised by 0, beta raised by 3. So actually, you don't need to be writing this, showing this raised by 0. So that is next time. So this is going to be alpha cube plus, so this is going to be 3 alpha square beta plus 3 alpha beta square plus beta cube. So, but you remember that what we are looking for is this. What our target is to bring these two together. These two guys, you are bringing them together. So this is going to be alpha plus beta cube. Then let's bring every other thing to the other side. That is minus 3 alpha square beta minus 3 alpha beta square. This will be equal to alpha cube plus beta cube. Okay, we are getting close to it. So, but remember, we are looking for alpha beta, not alpha square beta. So that means we need to take care of this by factorizing. So we take care of them by factorizing them. So, and in factorizing, we're going to have alpha plus beta cube. So what is common is minus 3 alpha beta. So when you divide this by minus 3 alpha beta, you are going to be left with alpha. So because minus, then the other one, so you divide this also, this will be plus, minus divided by minus is plus. So that is beta. So is equal to, is equal to alpha cube plus beta cube. Okay, so the next thing for us to do at this junction is to collect like terms and put our values into the formula. So let's switch sides so that we have alpha cube plus beta cube is equal to alpha plus beta cube minus 3 alpha beta alpha plus beta. Okay, so this is now the formula that we are going to use to solve this. So but in some textbooks, this is being given as a formula to memorize whenever you are given the cube. But I wouldn't encourage students to do that, because if you find yourself in an exam situation, cramming formula is not always the best. So this is something you can do in less than a minute. So just to derive it. So what you just need to do now, put your values. So we have alpha plus beta cube is going to be equal to, already we know that our alpha plus beta already is minus 2 over 3. So we put it in the formula. Put in the formula, which is minus 2 over 3 raised to the power of 3 minus our alpha beta is this. That's 4/3. So we put 4/3 as alpha beta. 4/3. So that's going to be minus 3 times 4/3 into brackets. Alpha plus beta is minus 2/3. So our alpha cube plus beta cube is going to be equal to minus 2 raised by 3 is minus 8. So this 3 raised by 2, that's 27. Then, so this 3 will cancel this 3. So this is going to be minus 4. So minus times minus, so that's going to be plus 8 divided by 3. So we simply find the LCM. The LCM is 27. So 27, that is 1 times minus 8. So plus 3 into 27 is 9 times 8 is 72. So finally our alpha cube plus beta cube is going to be minus 8 plus 72. That's going to be 64. Yes, 64. 64 divided by 27 is our answer. So this can be used to solve any question you have been asked using alpha and beta.